At the end of our last lesson, we saw how the flight of a golf ball creates a curved graph called a parabola. We said we were going to zoom into that curve. So, let's look closely at the numbers from our very first shot. At 1 second, it was 30 feet high. At 2 seconds, 48 feet. At 3 seconds, it hits 54 feet. But by 4 seconds, it drops back down to 48 feet. Because gravity is pulling the ball back to Earth, this parabolic curve opens downward. And because it opens downward, it creates a distinct peak, a maximum height. In math, we call the exact coordinate of this peak the vertex. Here, our vertex is exactly at 354. But what happens if we look at a different kind of ball? Think about a wrecking ball pulled high into the air and released. It swoops down and swings back up. This is also a parabola, but it does the exact opposite of the golf ball. It opens upward. Because it opens upward, there is no highest point. Instead, it has a lowest point. This is called the minimum. Just like the golf ball, this absolute extreme point is also called the vertex. If you are a demolition crew, this vertex is all that matters. The absolute lowest point of the swing is exactly where the ball is moving at its maximum speed. If you want to smash a wall, you position it exactly at the vertex. Now, there is one invisible feature that both of these parabolas share. Let's look at the golf ball data one more time. Notice anything about the numbers around the vertex? 1 second before the peak, the ball was at 48 feet. 1 second after the peak, it was exactly 48 feet again. At 1 second, it was 30 feet high. And if we track it forward to 5 seconds, it lands at exactly 30 feet again. The flight down perfectly matches the flight up. Parabolas are perfectly balanced. If we drop a vertical line right down the middle, straight through the vertex, the left side is a perfect mirror image of the right. We call this invisible mirror the axis of symmetry. So, whether a parabola models a golf ball, a wrecking ball, or just pure numbers, the key features are always the same. The direction it opens tells you if you have a maximum or a minimum. The vertex pinpoints that exact extreme value, and the axis of symmetry shows you its perfect balance. But notice, every feature we found today, we found by reading whole seconds off a table. What if the ball's real peak wasn't at a clean number like 3 seconds? What if it happened at 2.5 or 2.73? Our table wouldn't show it, and our graph could only guess. In the next lesson, we'll find the exact rule hiding behind these numbers and use it to answer questions our table never could.